Hey guys, what's up? So we've done a lot of work with definitions and given you some equations and things like that, but I feel like we haven't done enough actually practice using those equations. So tonight's homework is just going to be give you some word problems. You're going to try to figure them out. Remember, please do pause the video and try to figure it out yourself before you see my response. All right, but then I'll go ahead and show you how to use the equations, the definitions, the things that we've talked about to answer these questions. In class, you'll get a little bit more practice. Now, as we get into it, I apologize if there's weird shading and stuff like that. The video I had to take during the great blackout of 2022, so no power in the school. Deal with it, and hopefully this is all right. So, without further ado, let's go to question number 1.
All right, so here we go. We got a question about our friend Owen. Owen loves to run. He decides to run to Knorr shopping. Knorr is 800 meters from his house. Don't ask why I know, I'm just creepy like that. It takes him 2.5 minutes to get there. He takes a 1-minute break and then runs home. His average speed for the whole trip is 3.8 meters per second. Run, Owen, run. All right, so here we go. First question, what total distance does Owen run? Well, this should be pretty straightforward. He goes from his house to Knorr, which is 800 meters, and then he goes back to his house, which, assuming he goes the same distance, is going to be a total of 800 plus 800. That would be 1,600. All right, 1,600 meters. That is the total distance. All right. What is Owen's final displacement? Now remember, displacement is how far is it from your starting point to your ending point. So if he starts at home, he goes all the way to Knorr, comes all the way back, his starting and final point are in the same place. That means the displacement is 0. So he's got a total displacement of 0 meters for the whole thing. Now somewhere in the middle, he might have a different displacement, but beginning to end, displacement is 0. Number C. Let us see. What is Owen's speed to Knorr? All right, now this is where we're going to start using some of our formulas, some of the equations we learned. We learned that speed is equal to distance over time. So we need to figure out what the distance is to Knorr. We already know that. That's 800, so we'll put that in for the distance. And then the time, it says 2.5 minutes. Now, we want to make sure that we put this in SI units, which means meters and seconds. So I'm not going to use the 2.5 minutes here. I'm going to turn that into seconds. Now, you can do that however you want. I know that there's 60 seconds in each minute. So 2 minutes would be 60 plus 60. And then half a minute would be another 30 seconds. I add all those together, I get 150 seconds. So I'm going to go divided by 150 seconds. So the 800 is meters, the 150 is seconds. 5.3. So 5.3, and because I used meters and seconds, I'm just going to end up with 5.3 meters per second. All right, so that is his speed to Knorr. All right. Next question, what is his average velocity for the whole trip? All right, you may remember that velocity is equal to displacement over time. His displacement for the whole trip was 0. So it doesn't matter what time was, I'm going to get 0 meters per second. Now remember, that's because when he runs one direction to Knorr, he's going to have a positive velocity, and when he goes back to his home, that's going to be a negative velocity. The positive velocity, negative velocity, they're going to end up canceling each other out, and he's going to end up with a velocity of 0. All right, now this last one is going to be a little bit more tricky. It's going to be our hardest one. How long did it take him to get home from Knorr? Now, well, what do we know? We know his average speed for the whole trip is 3.8 meters per second. I don't know anything about going home from Knorr, but I do know the whole trip is 3.8. Now that's the average speed. Now if I'm talking about the speed for the whole trip, the speed was 3.8. This is average speed, so 3.8 equals the total distance. What's the total distance? Well, the total distance, remember, was 1,600 meters. So that's going to be 1,600 on the top. And then the bottom is the time. Now that's what I can solve for. I'm going to solve for what was the total time that it took him to go to NOR, take his minute break, and then come back. So I'm going to go time, and I'm just going to put a t on the bottom as my variable. So now I've got an equation, I can solve it. Okay, now one of the things I hope you learned in Algebra 1 is if your variable's in the bottom, the first thing you should do is get it off the bottom. Okay, so the first thing I'm going to do is I'm going to multiply both sides by t. And that means on the left side, I'm going to have 3.8t. And that's going to be equal to 1,600. Just like that. Those t's are going to cross out. And so now I'm just going to be left with 3.8t equals 1,600. So now I can just do 1,600 divided by 3.8. And I get 421. Now this is the total time. This is the total time. The question is, how long did it take him to get home from NOR? Well, this is the total time. That's 421. So I need to subtract off the 150 seconds that it took him to get to NOR. So I'm going to go minus 150. All right, that'll give me 271. And then I need to take off the 1 minute break as well. So that's minus another 60 seconds. And so my final answer is 211 seconds. So how long did it take him to get home from NOR? 211 seconds. So it took him a little bit longer to get home than it took him to get to NOR. That makes sense. From his house to NOR is down the hill. From NOR to his house would have to go up the hill, so probably going to be a little bit slower there. All right, there we go. All right, new question. Here we go. Yesterday, I walked to school. I walked 300 meters west, then 800 meters north. While talking to two physics students, Hassan said, so you live more than a kilometer from school. John said, no, that's not right. He's less than 1 kilometer away. There we go. Letter A. How can both students be correct? Okay, think about it. Let's go. Let's see if we can answer it. Well, how could both be correct? Number one, Hassan says more than a kilometer. Okay, well, 800 plus 300 is 1,100. That's more than 1,000 meters. That's a kilometer away. So how far did I have to walk? Well, I had to walk a total distance of 1,100 meters. That's more than a kilometer. Okay, kilometers, 1,000 meters. Okay, so Hassan's right. How could John be right? Well, think about this. If I go 300 meters west, north, south, west, and then I go 800 north, what is the actual displacement from point A to point B? As the crow flies, sometimes they say. Well, a squared plus b squared equals c squared. So you should be able to go 300 squared plus 800 squared, and then you square root that answer. And I get 854. So, how is John correct? Well, my displacement, the actual distance in a straight line from the school, is 854 meters. That, my friends, is less than a kilometer. So could they both be correct? Yes. It just depends on how they're looking at the situation. All right. Next question. At a speed of 1.7 meters per second, how long would it take us to walk the first 300 meters? All right. So looking at this, it's got speed here. It's got a distance here. It's asking us for how long, that's time. What formula do you know that connects speed, distance, and time? Well, hopefully you're thinking, well, Mr. Bauer, I know that speed is equal to distance over time. And I would say that is absolutely correct. because I can then say my speed is 1.7, which is equal to the distance, which is 300 meters, divided by the time that it takes to get there. Okay? Again, just like in the previous question, we need to get that t off the bottom. So I'm going to multiply both sides by t, and then it'll be 1.7 t equals 300, and then I'll divide by the 1.7. The time is 176 seconds. All right? Almost 3 minutes, right? 3 minutes is 180 seconds, so almost 3 minutes it would take us to go that first 300 meters. All right? Letter C. We walked the final 800 meters in 7 minutes and 4 seconds. What was our average speed for that 800 meters? All right, again, what information do we have? We've got a distance, we've got a time, and we want speed. So that's what we need, right? We can go speed. I'm going to go and do it over here on the side because it looks like I've got more space over there. So speed is equal to distance over time. Okay. The distance was 800 meters. And the time was 7 minutes and 4 seconds. Remember, we want this in seconds so that we're using SI units. So I'm going to take my 7 minutes and multiply by 60. That gives me 420 seconds. 60 seconds for each minute. But then I need to add on those other 4 seconds. So I'm going to end up with 424. So I got 800 meters on top, 424 seconds on the bottom. So now I go 800 divided by 424, and I get my speed, which is we'll round it to 1.9 meters per second. All right, 1.9 meters per second. So for whatever reason, we were able to walk that last little bit faster than the first little bit. We were going 1.7 there, now we're going 1.9. Okay. Next question. What is the average speed for the whole trip? Okay, now remember, you cannot just take the two speeds and average them. That's not how speed works. How do we calculate average speed? Average speed comes from distance over time. So same thing here. We're going to go speed equals distance over time. Do I know the whole distance traveled? Yes, I went 300 and then 800. We talked about this before. My distance is 1,100 meters. Do I know the total time traveling? Yes, because I know it took me 176 seconds to go that 300 meters. And then we talked about before, we had that 7 minutes and 4 seconds. Remember, that was 424 seconds. So I know how much time that took. So I know how much time the whole thing took, right? So I'm going to go ahead and add those times together. That 176 plus that 424. And that's going to give me a total time of 600 seconds. And now I can do 1,100 divided by 600, and I get a final speed, a final average speed of 1.83 meters per second. Now, if you look at this, it should kind of make sense. Okay? Is it between the 1.9 and the 1.7? Yeah, it's somewhere in the middle. It's kind of an average. Now, which one of those did I spend more time on? The 1.7 or the 1.9? Well, the 1.9 was a whole 800 meters. It was more time, right? That was that 424 seconds. This one was only 176 seconds. So our final answer should be closer to the number that we spent more time on. And 1.83 is closer to 1.9 than it was 1.7. All right? So therefore, our answer makes sense. Our answer is in the middle of the two, so it's an average kind of, but it is closer to the one that we spent more time doing. All right? So, very nice. we then have letter D. Final answer, final question, what is our average velocity for the trip? What is our average velocity for the trip? Now, how do we get velocity? Remember, velocity is displacement over time. Displacement over time. Remember displacement we already talked about. We said that we got 854 from the starting point to the ending point in a straight line. We did that earlier. So when we do velocity, we're going to do displacement over time, which the displacement was 854. We already did the time, which was 600 seconds. So we'll do 854 divided by 600. And 854 divided by 600 is 1.42. So 1.42, and it's still in meters per second. There we go. That's our average velocity. Now, velocity should also have direction, okay? And some of you may be comfortable with finding an angle here, right? You should be able to, if you've done geometry or algebra 2 trig or something, you should be able to get that angle right there using sine, cosine, and tangent. You could get that. That would be your direction. That angle would be your direction. Okay, for now, I'm not going to require you to do that because not everybody has done that yet. And so that would not be very fair of me to do that without teaching you how to do that. At some point later this year, we may learn a little bit of trig so that we can do some things like that. But for now, if you can find it, great, go ahead and do it. It's a great skill to be able to do that. But otherwise, I'm going to go ahead and just say, understand that velocity should have a direction, but this is the magnitude, at least, of that velocity. Okay, there we go. That's the end of that problem. Let's try another one. All right, one more question. Here we go. A car is moving to the left with a speed of 18 meters per second. The driver slams on the brakes and comes to a stop. Her phone's accelerometer says the car's acceleration while stopping was 3.5 meters per second squared. How long did it take the car to stop? All right, so this is our first question that's having some acceleration in there, but we did get an equation for acceleration. Do you remember what it was? Change of velocity over time. Okay, time always changes in the same direction. So we're going to need to calculate that. Now we know the acceleration. The car's acceleration was 3.5. That's going to be equal to the change in velocity. Now remember, change is final velocity minus the initial velocity, okay, over that change in time. Now, initial, we usually put a little 0 there. The 0 represents at time 0. That's why it's initial. It's at the beginning, all right? So final minus initial. So my final velocity, well, it does say that she's going to slam on the brakes and come to a stop. So the stop is going to, final velocity is going to be 0 minus the initial velocity. Now notice it says moving to the left with the speed of 18. Usually to the right is positive and to the left is negative. And so we're going to go ahead and put in a negative 18 meters per second there to show that the acceleration to the right is positive, that going to the left is negative. All right, and then divided by the time. Again, the time is what we're going to be solving for. We've seen this in the last couple of questions. Remember, we're just going to multiply both sides by t to get that t off the bottom. And then we're going to have 3.5t is equal to 0 minus negative 18, which is the same thing as 0 plus 18. So that's 18. And then we're going to divide both sides by 3.5. And so 18 divided by 3.5, 5.14 seconds. All right, so we're able to calculate how long it takes to stop. All right, so I hope that these examples have shown you how we can use our formulas to get different things. We don't have to just use distance and time to get speed. We can have speed and one of the other variables to find the missing third one. Same thing here with acceleration. I don't have to just start with velocity and time to get acceleration. I might be given acceleration and one of these things and be able to solve for the one that's missing. So there's some problem solving going on here You do need to pick the right formula. Make sure you pay attention to what is the information I have and what is the information I'm trying to get, because if you're looking for time, time could be distance over time, displacement over time, velocity over time, right? It could be a lot of different things. And so you want to make sure that you're picking the right equation for the situation. I hope you got a little bit of that today. All right, I'll see you in class, and in class, I'm going to give you a chance to practice more of these. All right, see you then.